From centuries, astronomers are doing their best to find out the mysteries of this known universe. But after all that effort, there are still some of the mysteries that is untouched. One of them is the star known as SDSS J102915+172927. For the record, the odd name serves the purpose though, as they are typically coordinates for where the star can be found in this cosmos. In 2011, a team of European astronomers discovered this star in the constellation of Leo. The star size is only 80% of our own. And the mysterious thing about this star is that its age is believed to be around 13 billion years old. As we know, the universe itself is around to be 13.7 billion years. This is to be considered one of the oldest surviving stars that we know of. And that's not it. The most mind-boggling thing about this immortal anomaly is that, according to all theories, this star shouldn't even exist in the first place. The star is made up of 99.99993% of hydrogen and helium, that is too light to condense and to form a star on their own. When these figures are put together into a simulation, the result always comes up is that such a star cannot exist. Astronomers are puzzled as to how such a star could have formed without the aid of heavier elements. This still remain a mystery. Talking about the mysteries, our friendly neighborhood galaxy Andromeda is full of it. Any person with an Apple computer should have a good idea what this galaxy looks like. This time, we are not talking about just one star, we are talking about millions of them. Almost 2.5 million light-years away, in the core of Andromeda galaxy, exists a supermassive black hole, like one enormous vacuum cleaner, so strong that even light cannot escape from its grasp. In 2005, the Hubble Space Telescope zoomed into the galaxy's core, and discovered a blue pancake-shaped disk rotating dangerously close to this massive black hole. But looking closely, the astronomers observed that this hot blue disk of dust is not just that what it seems. These are the young blue stars, millions in number, all of them zipping around the black hole at the velocity of 2.3 million miles per hour. That is enough speed to circle around the Earth at the equator in only 40 seconds. The thing about this disk is that the tidal forces around the black hole is so strong that it is impossible for any star to form around it. The gases which formed the stars and stars themselves should have been torn apart by the immense gravity of the black hole. Have you ever been in a disco? If not, then I introduce you to the V838 Monocerotis, which was located 20,000 light-years away from the Earth, and was at one point considered one of the largest star in the universe. In 2002, the brightest of the stars shot up suddenly. It was thought to be a simple nova, but less than a month later, the star burst into light again. Since the time period between the explosions was too short to be caused as two separate novas, astronomers were puzzled by seeing the phenomena. After a closer look, they found out there was no white dwarf. The star has simply erupted by itself, and it repeated this process, brightening and dimming several times over the next few months. During its brightest eruption, the star becomes 1,000,000 times brighter than the sun, and one of the brightest light in the sky. Typically, stars brighten slightly before their death, but measurements indicated that the star was only few million years old, which mere toddles in star's life. When the Hubble telescope captured the image of the star, after the explosion, a cloud of gas and debris was moving away from this star. One of the theory has suggested that the star might have collided with another object that might have been another star. Talking about the behavior of a star, this one is much stranger than the above. The planet KIC 8462852 is observed by the Kepler telescope. This telescope actually observes the dips in the brightness of the star whenever the planet comes in front of it. But with this star the dips are a bit different. Whenever a planet passes, a tiny fraction of starlight is blocked, and we can see a dip in its brightness. The bigger the planet, the bigger the dip in the brightness. It's the easier it to spot. But where a planet like Jupiter would cause the starlight to dim by just approximately 1% as it passed through. But with the KIC 8462852, the dips are huge. The largest being 15% to 22% of the starlight fading out, then brightening again. That in itself is strange. But there's more. For a planet that the winks generated would be periodic, as one orbit, one wink. Here, the dimming KIC's brightness are not periodic. The two of the largest occurred roughly 730 days apart, but smaller dips have also been seen. And the most recent largest drop, 22% of the starlight, was followed by two other smaller dips over the month. And the reason? We don't know. This might be anything. In this world anything is possible. When I was a kid, I was told that, if we make a wish from a shooting star, that wish will come true. But after some time, I realized, any wish of mine is not being granted. Then the day came, when I faced a heartbreaking truth, about these so-called shooting stars. They are not what they were. These shooting stars are the debris, that caught by our Earth's gravity. At that time my heart was broken. But then, I came face to face with Myra. No, it's not some kind of angel, it is the star, situated in the constellation of Cetus. The whale. Over 420 light-years away. It is an unmarkable patch of light, in the night sky along the celestial equator. This star varies in brightness. The changes happen on a regular schedule of about 11 months. Myra's last brightness peak was in March of 2016, and the next peak is scheduled to be around February 2017. The brightness peak of the Myra is 3.5 magnitude, putting it below the brightness of the other star in Cetus, the whale, and at the dimmest, Myra falls to 10th magnitude, below to visibility limit of modest binoculars. And this is not it. The most astonishing fact about this star is, in 2007, observation by a satellite, viewing in ultraviolet light, discovered that Myra has a luminous tail of gas, more than a dozen light-years long. This is the material of Myra has shed, leaving it behind as it speeds through the galaxy, at the speed of 80 miles per second, or 130 kilometers per second. That's the reason I call it a shooting star. And that's why for centuries stargazers named it Myra the Wonder.